Hello everybody. Today we're looking at water as a solvent of molecules. We're going to look at some vocabulary, some molecules that form hydrogen bonds and so do dissolve, some other molecules which ionize and so dissolve, and some molecules that don't dissolve. You'll remember that a molecule is a small collection or maybe a large collection of atoms which are joined together with covalent bonds. Now, water is a molecule. It forms hydrogen bonds. So here we've got a couple of water molecules. This one's drawn with the lone pairs of electrons drawn in, but normally we don't draw those. But the oxygen atom draws the electric charge to itself, leaving the hydrogen atoms relatively positive, and so you get a little hydrogen bond forming there. Another polar molecule is this one here. This is ethanol. This is an oxygen atom here, hydrogen atom here, and two carbon atoms. Once again, the oxygen draws the electrons away from the hydrogen, so this here becomes slightly positive, and so this is a polar molecule. This one over here is hydrogen chloride. Here's hydrogen chloride, HCl, is also a polar molecule. The chlorine atom here draws the charge away from this bond, away from the hydrogen atom, and leaving hydrogen atom slightly positive, and the chlorine atom is slightly negative. This molecule over here is butane, another kind of molecule. Now, just to talk about the hydrogen chloride a little bit more, it can ionize. Now, if you look at this here, what's happening here is that the bond is breaking, and the chlorine is taking both the electrons, and so it gets a negative charge on it, and the hydrogen doesn't have its electron with it anymore, so that one gets a positive charge. That's called ionization or dissociation when it's with water, in terms of in aqueous solution. Now, as we mentioned before, some molecules will form hydrogen bonds between the molecules, and here we have three alcohol, the ethanol molecules, and the negative charge on this oxygen atom here will attract the positively or slightly positively charged hydrogen atom on the next molecule, and so that's a hydrogen bond forming there, and another one will form here. So ethanol molecules tend to stick together because the hydrogen bonds will stick one to another one. Now, if you take ethanol and you put it near some water, the molecule can come close to some water, and what happens is that when it gets close like this, you actually get hydrogen bonds forming between this water molecule and this one, this part of the atom here, this part of the molecule, and the oxygen in this part of the molecule here will get attracted and form a hydrogen bond with the water there. And that's enough so that the whole molecule basically gets taken in and surrounded by the water molecules, and so the whole thing will dissolve because those hydrogen bonds there, these ones here, here and here, those hydrogen bonds are enough to suck that whole molecule into the water, and that's what dissolving means. It gets absorbed into the water or taken into the water. Now, I've got another molecule here. This one is vitamin C. If you have a little look at the structure of it, it's a little bit complicated, but you can see an OH there, and there, and there, and there. So these are polar parts on the molecule. So this has got a lot of polar functional groups, a lot of polar parts on that molecule. I'm going to draw it slightly differently. I'm going to draw it with those all shown up. And when this molecule comes in contact with water, then you get hydrogen bonding happening here, and maybe between this hydrogen here and this water molecule here, and maybe from here across to here and here to here. So this molecule gets a lot of very strong bonding with the water molecules, and so that allows it to dissolve. So vitamin C is soluble. That means that it will pass out of your body in your urine, and so you're always losing a little bit of vitamin C. That's why you always need to get vitamin C in your diet, because you're using it up every day. Now here's another molecule. This one is vitamin A. Now vitamin A does have only one polar part to the whole molecule. That's not very much. Let's draw it slightly differently. And here's the oxygen and the hydrogen here. So when vitamin A comes in contact with water, you do get the hydrogen bonding occurring, but it's only one hydrogen bond, and look how big this molecule is. And that one single hydrogen bond there is not enough to allow this whole molecule to break into all this water. So the molecule might get sort of drawn in a little bit, but it can't actually get taken into the water, so it's not soluble. That means that if you don't have vitamin A in your diet every day, not a big problem really, because you're not losing it through your urine every day, and so you can go for a little time with a little bit less vitamin A and it's not going to be a problem. Okay, so that one won't dissolve. Here's another molecule that won't dissolve. This one is hexane. It's not a polar molecule, so there's no hydrogen bonds forming. So when this molecule comes in contact with water, there's no real strong attraction. It doesn't dissolve. Now another molecule we're going to look at now is a different sort of scenario. This is a highly polar molecule. This is hydrogen chloride. Okay, so it's hydrochloric acid, HCl, hydrogen chloride. Here's the chlorine atom here, and here's the hydrogen atom. And this molecule is attracted so strongly to the water that it actually breaks up and becomes ionized, turns into two ions. So the chlorine then gets a negative charge on it like that, and the hydrogen gets a positive charge on it because the two electrons they're in the bond there, those both are now on the chlorine atom. And what happens is that the chlorine ion will actually move into the water, and you get hydration. So that means basically the chlorine is surrounded by water, and look, the positive parts of the water molecules are lining up with the negative charge on the ion, and so that whole thing is very stable because it gets surrounded by water. And the same thing happens to the hydrogen ion. It can move into the water and it gets surrounded by the negative side of the oxygen atoms in the water. And so there's an attraction happening there and there. So this has got a positive charge on it. And so the negative side of the water gets attracted to the proton, now the hydrogen atom, hydrogen ion, and that's a very stable situation. And so that one will now that it's ionized, that will dissolve as well. So in summary, if a molecule is ionized, then it will dissolve into water, or if it's got plenty of places where it can form hydrogen bonds, then it will dissolve. If it doesn't have any of those characteristics, like oils and like vitamin A, then it won't dissolve. Thank you.